Hello, this is Dan Baker, Research Director of Technology Research Institute, and I'd like to welcome you to the Vanilla Plus Thought Leadership webinar series. Now in its 12th year of publishing, the Vanilla Plus magazine, online editions, and newsletter provide keen insight into the telecoms market, especially for operators in Europe, the Middle East, and Africa. Today we're delighted to introduce Nexus Telecom, who will discuss the topic, Kill the Network Fiefdoms, how to gain business control through real-time intelligence. And representing Nexus is Stefan Crome, the company's product manager for BOSS Solutions. Welcome, Stefan.
Thank you, Dan. Welcome everyone to this webinar, and I'm glad to explain to you how we kill network fiefdoms using our systems.
Great, Stefan. Now, a couple of housekeeping notes first. At the bottom of your screen, you'll notice there's a place for you to enter any questions you may have for Stefan and I. We've allotted some time at the end of the webinar to answer these questions. And those questions we don't have time to answer, we'll forward to Nexus Telecom for follow-up. We also invite you to participate in an audience poll that begins about halfway through the webinar. Okay, the subject of this webinar is killing the fiefdoms, and so what's that all about? Well, actually, there are some very interesting parallels between the feudal age and the telecom industry. As you know, feudalism was based on fiefs, or fiefdoms, tracts of land inherited and overseen by a lord. The feudal age's basis in land is similar to the telecom carrier's traditional operating territories, of course. And the picture here depicts the Notre Dame de Reims Cathedral in France, as it looked in the 13th century. Notice the twin towers of the cathedral, and I think we can safely say that the power and influence of the cathedral in those days is analogous to the height of those towers. The bigger the towers, the more psychological power the archbishop had in transmitting the word of God. In a similar way, the strength of a wireless operator is based on the height and transmission power of its cell towers. Now, the arrival of the great feudal age cathedral signals a time of relative political stability. People had enough food to eat, so the resources were there and available to build a large cathedral, which may take several years to complete. Now, a decade ago, of course, a similar stability existed in the wireless telecom market, where competitors in a region were few, and there was a direct relationship between the infrastructure that you built out and the carrier's future revenue growth. Unfortunately, of course, the feudal age came to an end, and the historians point to several reasons for its decline in Europe. First, the arrival and use of gunpowder and cannons made it much harder to defend the feudal lands. Then the Black Plague arrived in the 14th century and killed an incredible 30 to 60% of the population, which of course greatly shook the stability of the system. Third, and perhaps most significant, was the arrival of a merchant class, people who gained money by making and selling things. Their wealth was based not on land, but money. So eventually feudalism kind of collapsed on itself because it was a system built on inherited territory, and it no longer fit the way the world worked. Okay, now looking at the telecom industry, we're going through a similar revolution today. A telecom scale of operations, territory, and spectrum are still very important. However, with the arrival of greater industry competition, smartphones, mobile money, and the all-IP technology that LTE brings, telecom profitability and revenue growth is much harder to attain and predict. Telecom is becoming less feudal and more merchant class. And a merchant class survives on speed, market intelligence, and operating agility. Okay, so what's a good business model for the merchant class era? Well, I suggest we take a look at Apple as a business model. In the last few years, Apple has actually become the most highly valued technology company in the whole world. And so the question begs itself, how did it overtake Microsoft? And how can a company of Apple's size grow its revenues organically by 60% in 1 year? I mean, this is an incredible business success. Now, as luck would have it, in the last month's issue of Fortune magazine, in the U.S. edition, is a remarkable investigative expose on how Apple is managed, and it's entitled, From Steve Jobs to the Janitor, How America's Hottest and Most Secretive Big Company Really Works. So let's talk a little bit about how Apple is organized for success as explained in this article. I've adapted this diagram from the Fortune article, and it shows the organization structure at Apple with Steve Jobs at the center, senior vice presidents in red, direct reports in gray, and a few dozen vice presidents in blue. Now, when many people look at the astounding success of Apple, they attribute it to the vision and leadership of Steve Jobs himself. But even if you grant that Jobs is a business genius, which I'm convinced he is, I mean, his leadership doesn't really stand on its own. Apple's success is embodied in a system, the people, processes, and machines that together allow Steve Jobs to bend this $88 billion company to his will and respond to current market conditions very quickly. Now, looking at the diagram, there's nothing particularly magical about the way Apple is organized. In fact, it's organized much like a small business rather than one of the largest corporations in the world. What we have here is a company that's run by tight command and control. It's almost like a military organization. I mean, Steve Jobs is like an industry field general who can quickly marshal his resources and forces on the field and win in the market battlefield. And notice the silicon chip design of the diagram is meant to show that Apple operates its business in real time. The vice presidents at Apple are held strictly accountable for their success. And so when they fail, they can't very well point their finger at anyone but themselves. Also, Apple's 40 or so top managers in this rank have functional responsibilities, all right, but it's not as if they can lord over their fiefdoms and develop an internal culture and operate somewhat independent of corporate. It doesn't work like that. At Apple, the line managers take their marching orders from a weekly management team meeting overseen by Jobs. Now, I think it's particularly telling to listen to some of the comments from some of the former executives at Apple about their ability to operate in real time. And here are some of the comments, which I'll read briefly. If the executive team decides to change directions, it's instantaneous. We've been known to change our pricing 48 hours before product launch. We get regular positive feedback in product design or are told to stop doing stupid stuff. And finally, Apple can quickly shift gears to seize opportunities. Okay, so where do the telecoms stand in terms of operating their business like Apple? Well, they certainly have a long way to go. I mean, the irony is that telecoms manage some of the most advanced technology of any industry on the planet. And over the past years, 2 decades or so, they've successfully bridged the worlds of plain old telephone service and analog wireless, and are now offering, of course, broadband, 3G, 4G, wireless, and other network technologies very successfully. That's been good. However, there's still a big problem, and it relates to this lack of real-time intelligence, flexible systems, and command and control style organization techniques that Apple employs so well. The fiefdoms or silos in telecom organizations are a very big issue. Just look at the wide gulf and cultural divide that exists between marketing and customer care, billing and operations, or GSM and LTE. When you launch a new wireless service, you can't look at the radio access network alone. You also need to measure congestion in the core of the network. But that visibility is very hard to get. And what about the market uptake for the new service? Is it enough to justify the price? Are the right demographic groups signing on to the service? And is there a major break or something else wrong with the service itself? You could be losing customers because you've overloaded a circuit and the people signed up for the service have abandoned it because the quality's not there. You need that feedback fairly quickly to take action. You need to be able to adjust your plan because the IP services environment, 1,000 things could go wrong. At service launch time, this information is absolutely critical. And the secret to gaining that intelligence is to take monitoring information on the OSS side and combine it with business or BOSS information on the business side. Okay, here's where I think telecoms need to go. You've probably heard the term smart grid, the notion in the electric industry where intelligence is gathered in real time from houses, factories, and utilities, and the electric rates are adjusted to meet supply and demand. Well, it may take decades, I think, for the utility industry smart grid to get built, incomplete. But telecoms, on the other hand, are actually pretty close to this smart grid formula. In fact, most of the network pieces are in place. All that's really needed is what I would call to electrify that telecom infrastructure so it can operate in real time. And the secret to doing that is to apply intelligence, human processes and machine analytics, and to take that intelligence from one side of the operation to another. Well, Nexus Telecom is a company with experience closing this real-time intelligence gap between BSS and OSS systems. Headquartered in Zurich, the Nexus name is rather appropriate for a company that is at the center of BOSS action. And even though the Nexus brand is not well known yet, the company has an impressive list of client references such as AT&T, BP, Telecom Austria, Beeline in Russia, Telstra, and Deutsche Telekom. Nexus's skill sets cut across two major functional areas. First, it does full network service monitoring, testing, and customer experience analysis, and it knows a lot about BSS systems too. For instance, its billing mediation is installed at Mobilink Pakistan, where it collects usage data on 65 million subs. Now a bit about Stefan Crome. For the past 3 years, he has been responsible for product management and marketing at Nexus for their BSS solutions. Before Nexus, Stefan worked for nearly 10 years with Nortel Networks in everything from new product introduction trials to pre-sales and product management. He has a working knowledge of core networking technologies such as carrier VoIP, IMS, IP MPLS, carrier Ethernet, and so forth. And Stefan holds a master's degree in electrical engineering from the RWTH Aachen Technical University in Germany. So, Stefan, it's now time for me to pass the baton to you.
Thank you very much, Dan, for this great introduction. And let's now have a look at the network fiefdoms implemented in most operators today and how we can actually gain a competitive advantage through real-time intelligence and overcoming the borders between these fiefdoms. The agenda for the follow-up slides of this webinar, it looks like this. We will first look at the typical network fiefdoms and the vertical silos that are implemented in most of today's network operators. We will then show how a centralist network governance can overcome these issues related to network fiefdoms. And finally, we will see how we can convert the fiefdoms to contributing functionality units. Let's first have a look at some of the fiefdoms that we typically see in today's operators. There is customer-facing units, customer-facing divisions that operate customer relationship management systems or customer experience management systems. We have a marketing division that does forecasting and pushes the products and new services into the market. Fulfillment is responsible for actually deploying the new services and making sure they function well. And this is also part of the functionality of the service assurance division. The service assurance division uses different service assurance systems in order to make sure that services are delivered at the appropriate quality of service and appropriate quality of experience to the end customers. Ultimately, network operators want to make money, so billing is a very important functionality that needs to be integrated, but that today is mostly part of the IT departments and therefore not integrated into the rest of the OSS/BSS infrastructure. There's other systems that are responsible for the resource management. At the end of the day, operators also need to procure services from their suppliers and partners. The procurement division uses its own systems again. Another fiefdom is, of course, the day-to-day network operations. This is the network operations center using systems for troubleshooting. And these are also, in many cases, decoupled from the rest of the OSS infrastructure. And finally, when we roll out new services, there needs to be a pre-in-service testing division using specific testing devices that are again disconnected from the rest of the OSS landscape. So how do we bring all of this together? The important part is actually to be able to load information into an integrated service quality management system that monitors the quality of service for each of these different devices, services, and divisions in the network operator. And as mentioned before, it's not just about service quality in a highly competitive market, but it's also about being able to bill for these services and to avoid any revenue leakage. And integrating the billing and revenue assurance systems is, of course, then also a very important part of the overall integration of different network maintenance systems, OSS, BSS systems, to overcome the network fiefdoms. So what is the situation in most operators these days? The systems are actually hosted in silos. So they are really enclosed in silos that collect the information from different network devices, different element management systems for the different divisions. So we have, for example, here just picked a few divisions that serve different customer segments, such as the mobile prepaid segment, the mobile postpaid segment, and the broadband DSL segment. The information is then uploaded in different separate databases, and ultimately reports, dashboards are generated from this information that help the operator to manage the different divisions. For example, for broadband, we would have associated messaging services that we monitor, or for the mobile market, you would have voice services and mobile data services that we monitor. And all of this information is then forwarded to different internal customers that use the information to run the network. The disadvantage of this is, of course, that information logged into silos cannot be used by other divisions in the network. And operators today have actually tried to connect the different silos or different systems in the silos by point-to-point interfaces. So in this example here, we would have, again, a mobile postpaid division of the business, would have a value-added services division, a broadband division, and all of these different divisions serving different customer segments have their own means of deriving data from the network and from the element managers and storing them in separate databases. And then they connect these databases and the different systems by using point-to-point interfaces. This, to some extent, helps the operators to overcome the fiefdoms and get a unified single network view on resource performance management, service quality management, and ultimately the customer experience. However, the problem with that is that whenever the operator needs to do an upgrade, awkward scripting and programming has to be done to adopt these point-to-point interfaces. And that makes it a very costly exercise. So we get to somewhat of a unified view, but this really comes at a cost. And what our systems will actually be able to do is to overcome these silos. Before we go into somewhat more detail on how we actually do this, I would like to hand it back to Dan, and we would want to do an opinion poll on your siloed systems.
Okay, audience, you now see this question ahead of you, and I will briefly read it here. If you could magically integrate 3 of your current OSS/BSS silos today, which ones would deliver the biggest benefit to your organization? And please check a minimum of 3 of these systems below. And you begin now, and we'll comment as the results come in. Okay, I think we're getting some pretty interesting results here. And service quality management, clearly on the OSS side, is much higher than in the other categories. We're also getting a pretty high score in billing and revenue assurance. So it really cuts across both BSS and OSS, it looks like. And service quality management, is probably the more sophisticated. It seems like people are not having as much trouble with the network systems, such as alarming and fault management, but the more sophisticated service quality is where the integration is needed. That seems a little bit surprising to me. What do you think, Stefan?
Yeah, that's actually a very interesting result that to some extent we actually expected. The real interesting thing is that we got the most votes for the service quality management, the classic resource performance management, and the customer experience, and of course also the billing and revenue assurance. And that is really, at the core of our solution to integrate the billing and revenue assurance part with the service quality management. You monitor the service quality that you deliver to your customers to differentiate yourself from the competition, and at the same time you actually link this to the billing and revenue assurance systems. And it's really very interesting to see that most of our audience would want to see precisely these systems integrated and removed from the silos.
Very good. Okay, please continue, Stefan.
So the next step towards OSS BSS integration is actually introducing a central network governance. And the idea here is based on the experience that you probably all know, and we have this little cartoon here where the boss comes in looking at the operations manager who's drowning in data, just asking, looks like you've got all the data, what's the holdup? Why don't you go ahead and provide the information we need to operate the network? And the issue really is the slice and dice within a centralized repository, centralized data warehouse for all of this information is very difficult if you don't have integrated data. And this is further increased by the complexity that you need to introduce in order to remain competitive. In the past, we had a classic standard reporting, which just looks backward at the past and explains what happened. This is certainly not sufficient to compete in today's markets, and the next step would actually be the capability of doing ad hoc reporting. There you measure how many, how often, where certain issues, instances have happened in the network. This is called the ad hoc reporting, but this is still a backward-looking capability. The next higher level of sophistication would be drill down. So you have dashboards and reports, and you're now able to dynamically drill down to the specific problem that causes the issue. This is still backward-looking, but it will significantly speed up the capability to do troubleshooting and to identify the root cause of a problem. Then comes a step which is already to some extent forward-looking, and that's the capability to generate alarms and alarm notifications. So this answers the question, is any action needed? And action would, of course, be something that happens in the future. So to some extent, this is forward-looking. Being able to simulate the future in your network using what-if scenario, what would happen if, is clearly a forward-looking capability of the OSS BSS systems. And taking it even one step further, machine learning would actually allow for prediction of what will happen next. And finally, network optimization is, if you want, the highest level of complexity in an OSS BSS system. So with such systems, you would be able to optimize the network based on forecasting. And of course, all of these capabilities, the more advanced and the more complex they are, will give you a significant competitive advantage. However, it also means even more sophistication, because you will have all these capabilities ideally in all of your systems for different divisions serving different customer segments. So the point is, how do we integrate all of these? The answer to that question is actually the data flow integration layer. So instead of having point-to-point interfaces that would connect the different devices of the OSS layer and the BSS layer, we will introduce an OSS mediation layer, also called data flow integration layer. So if you look at the bottom of this slide, you see different OSS systems such as probe-based, active or passive probe-based systems. You would have operational data stores. Of course, you have a plethora of different network element types and network element managers. And all of these systems produce information in CDR format or can be pulled and generate different types of file formats and use different types of file transfer protocols. In order to adapt these, we need to have different plugins. The plugins actually plug in the OSS mediation layer, that is, if you want, a data bus that exchanges all of the information between the different OSS systems and the BSS systems. BSS systems, again, use different types of data formats and data transfer protocols. And again, we use the plugin approach to adopt all these. The BSS systems can be anything from fraud detection, revenue assurance systems, enterprise resource planning, customer relationship management systems, or data warehouses. And also, at the higher level, we have customer experience management systems that measure the overall customer experience provided by different network divisions. And instead of having these point-to-point interfaces, we are now able to exchange information between all of these different systems, either single to single or single to multiple, multiple to single, or even multiple to multiple. We may, for example, want to collect information from a probe-based monitoring system such as Nexus NetView and distribute this information to various downstream systems. For example, customer relationship management systems, the data warehouse, but as well to the customer experience management system. So this gives us much more flexibility and really helps us to overcome the silos into which today's OSS and BSS systems are actually locked. Now, let us look at some examples of how these different views actually look like and how these views cater to different divisions in the network. Call this the business intelligence pyramid. At the bottom of the pyramid, we have the classic resource performance management with a network focus. So these are classic performance management systems. Those are systems like fault management systems and so on, helping to run the network on a day-to-day basis and managing the network resources at the network level. The next high level of sophistication is the service quality management. The service quality management has a service focus. So now we're not focusing on the network and the network devices and element managers anymore, but we are focusing on the quality of the end-to-end services. So this is a different audience again. Those are product managers using those systems that are responsible for proper delivery, availability, and quality of the services. And at the peak of the pyramid, we have customer experience management systems. These systems are actually directing the information to the quality managers that look after the customer experience at the various stakeholders responsible for the overall end-to-end perceived quality of the services. And what that actually means, providing different views for different types of audiences in the network, we've actually put together in a few screenshots here. This is a high-level dashboard that connects service quality, customer experience, and the billing experience in one single dashboard. On the upper left-hand side, we have the average revenue per user for different lines of business. These lines of business are typically enterprise, residential, and so on. And this gives us a single red, amber, green view of the overall revenue per user. And for example, we see here that in the residential market, we may have an issue. We can click on this and drill down and actually nail down the root cause of the problem. On the upper right-hand side, in parallel, we monitor the service quality. So this is the service quality management part. We can at the same time monitor critical resources in the network and the performance management or service assurance system itself. So this is the lower right-hand part of the dashboard where we see the system health. Overall, this is a view that you may want to look at as a chief operating officer, for example, when you come into the office first thing in the morning. Another view is now focusing on the resources. And as Dan mentioned the smart grid before, we've actually taken the step to integrate inductive power probes into the system, so we can actually pull these probes and upload files from these probes or CDRs from these probes in order to look at the power consumption of each and every network device. This actually comes as a simple power bar from which we upload information, and we generate diagrams like this one here where we can see the utilization of the devices. In this example, we're looking at a server farm delivering various services ranging from video on demand to voice and other services. And we also monitor the temperature of the devices in a single dashboard. And here we can identify, for example, devices that are high on power consumption but low in utilization. Those might be potential candidates for replacement. So this is the resource performance management view. And another one on the resource performance management level is this wireless circuit switch dashboard, where we look at certain parameters related to a mobile network. So we have messaging services, we have call attempts, and this again is in the mobile core a look at the different resources and the performance of these resources. Now, let's take it one level further and look at the service quality. We've added here 2 more dashboards monitoring the service quality. And in this example, we're looking at a video-on-demand service. We call this video-on-demand cockpit. This is just one example for a specific service provided to residential customers. And again, we have a red, amber, green dashboard here that monitors the overall service quality. For example, you see key performance indicators on the video delivery, such as zapping times for an IPTV service, the jitter delay packet loss, the space parameters, as well as frame freeze, and so on. We also monitor the critical resources along the path across which the service is delivered. So this actually starts at the server farm where the video server sits, via the head end, the core, metro, access networks, and finally the set-top box. Again, we have a red, amber, green dashboard and can click on each of these symbols in order to learn more about the issues related to a particular step in the path of the end-to-end service delivery. On the upper right-hand side, we have a few gauges that again describe the network load overall and other pertinent KPIs related to the transmission quality of the video service. And finally, we also have a short-term forecast capability in this dashboard where we actually can use a slide in order to change the projected growth for the network, and then we see what impact that will actually have on the load. So these are service quality management related dashboards, and on top of all of that, if you remember the pyramid, we have the customer experience. And an example of the customer experience dashboard is how are my roamers doing. This is basically a map that shows the roamer activity and whether they all have access to the network, as an example of an operator running a mobile network that has many roamers in different countries. And ultimately, we have here a dashboard describing a specific segment, in this case, the young professionals. What you get when you first open this dashboard is actually the view on a specific user, and you will see the customer segment to which this user belongs. If we then click on the customer segment, we see these pie charts that actually divide the users in different groups, in this case in females and males, and you see the different regions. So how many young, high-spending professionals do we have in each of the regions of the country? We can then measure the customer care experience. How many calls were needed to resolve a problem when calling the operator's call center? What's the speed of the answers, and so on. You measure in the upper right-hand side the service experience, and the service experience is basically here measured by looking at certain services or service bundles, such as a mobile TV service or the messaging service or the voice service itself. And finally, if you remember the introduction, of course, at the end of the day, we want to measure the billing experience. We want to make money as an operator, and therefore it's very important to have a unified view of the customer experience and the billing experience. Did the customer actually report a bill shock? How many times did customers call that complain about their bills being too high? How quickly have these complaints been answered? So the customer experience is actually a unified dashboard that shows the customer experience from a service quality point of view as well as from a billing experience point of view. And one of our largest North American customers is actually just rolling out the new release of Nexus Meter using precisely these dashboards. And the interesting part for them is that they can really monitor services end-to-end and at the same time monitor not just the telecoms network but also the IT infrastructure. And bringing this all together lets them really get a unified view of the service itself from the server farm to the set-top box. And that actually takes us to the end of the presentation, and we would now be ready to answer questions. I hand it back to Dan.
Okay, Stefan, thank you very much. I mean, it's a very impressive, these graphs and so forth. It shows you. I like the way you progressively kind of got down to deeper and deeper levels. It was very interesting. And we have 3 questions, and I will say to the audience, it looks like we're going to have some time to answer more questions. So if you do have something to ask, please ask it right away, and maybe by the time we get through these first three, we can get to you too. All right. My first question, Stefan, is really about, here it is. Does centralizing the business relevant information into a single source of truth also, does that also mean that the OSS/BSS landscape is more susceptible to downtime and outages and so forth? Do you understand that?
Sure. The key to having a reliable centralized system is actually carrier greatness. That means that we have no single point of failure in the system. So, of course, centralizing the system and providing different views from a central source of truth means that we have to have an absolutely reliable system, and we achieve that using resiliency for the polis, for each of the collectors, as well as for the central service. And this is really a key topic here. We also provide geo-redundancy with the system, so no single point of failure and geo-redundancy are actually key.
Okay, very good. Here's a second question from the audience. How do you ensure, when you have integrated data flow management, how do you ensure that that scales for a large CSP's customer base and network sizes? So this whole notion of scalability.
Scalability is indeed very important for such a system covering the carrier as a whole, and we achieve this using clustering. So each of the central service as well as each of the collectors and polis can actually be clustered, and that means that we can scale the system to any size.
Okay. Okay, great. And the third question, does the configuration of the data flow and the different formats, does that require some special programming skill, or do you have a scripting knowledge in your solution?
Well, one of the key features of this system is actually a graphical user interface that avoids any need for programming or scripting. That means that the data flow, the data formats themselves, and the different data transfer protocols can all be configured using a graphical user interface. You literally pull together the data format by pulling together the fields of each new data format once you know the data format type, and in that way you can very easily create new plugins. So if, for example, an upgrade has to happen in the network and some of the data format fields change, for example, 2 fields are added to the previous data format, you can actually reflect that in the system very quickly. You can just model the new data format by pulling in the 2 new fields. So it's all graphical, and also forming new key quality indicators and quality of experience indicators can be done using a graphical user interface that lets you form complex expressions, but you really don't have to do any scripting or programming.
Okay, and a related question has come in. Are the dashboards all fixed, or they're looking for more detail on how it actually works?
All right, so no, the dashboards I have been showing here are just examples, and the dashboards are highly flexible, which means that the user can pull together his or her own dashboards. As an example, I had this initial one which provides a general view that you may want to have when you come into the office first thing in the morning, and these dashboards are really highly flexible. The whole idea is having customized dashboards that the users can actually pull together themselves very easily to slice and dice in the centralized data and provide precisely the view that each of the users may want to have.
Mm-hmm. Okay. And, it has graphical capability, but do you also, I noticed that it's nice also to be able to enter, more precise information by text mode. Can you also modify the graphical to, more precisely, modify the look?
I think what you're referring to is drill down capability.
Yeah, but but also, it's great to have a graphical user interface, but it's also nice to drill down and have a more accurate look that the graphical flow might not be able to give you.
Well, what you can actually do with each of these dashboards is you click on a, for example, red, amber, green symbol, and that then will bring you to another graph showing the performance or showing the KPI in somewhat more detail. So this is not just a simple drill down capability, but you can also, in some cases, drill up. One of the examples I mentioned was the last dashboard that I've been showing on the customer experience for a particular customer segment. And the pie charts we see here are a drill up from the user. So the first thing that you would see when you bring up this dashboard is the name of the user and what segment he's a part of and all his billing history. And then you actually see that this particular customer, the single person, is part of the high spender young professional segment, which is of course very interesting for any operator. If you just click on the name of that segment, this will get you to the pie chart that we just see in the slide here. So we can drill up and down in any form and to some extent also modify the look and feel of each of these graphs.
Very good. Okay. Okay, and so we have one final question. I think modifying in real time, can you drill down to the raw data, actually?
Absolutely, you can do that, and raw data reporting has been an important part of the previous releases of the system, and of course this is still part of the existing system, so you can really drill down to the very level of the raw data.
Excellent. Okay. Great. Well, that concludes the questions that we have, and I want to thank you, Stefan. Okay, wait a minute. We got one more coming in. Might as well get to this. How about providing different people in the company different views? And the second related question is the system secure?
Okay, I guess these are two separate questions. Of course, we can provide different views, and this is actually what I tried to explain when I looked at the different dashboards here. So different divisions in the company have different user access rights, and we have actually highly flexible LDAP-based user management. So the whole AAA is centrally managed, and that means that different users can get different views on the dashboards. They can slice and dice, and providing different views is absolutely no problem with this system.
And security?
Well, security is, of course, part of the user management that I mentioned. So the AAA authentication and authorization is an integral part. As I mentioned, this is LDAP-based, and this, of course, makes it a highly secure system that only spreads the information for those eyes who are supposed to see it.
Great. Okay. Well, this is great discussion, Stefan. I want to thank you very much. I think it's very enlightening how you can, in my analyst work, I'm doing a lot of work in the revenue assurance and billing areas, but it's interesting to see how these worlds of service assurance and revenue assurance are going to eventually merge, and I think you guys are showing how this can actually practically be done today. And it's very, very interesting to see this development, and I'm sure that it's kind of a trend going forward because operators really need this to fight these silos and to extract intelligence. So I want to thank you, Stefan, for your presentation, and I want to we'll close the webinar at this point, and I'll remind you, everyone in the audience, that in about a week's time, this webinar will be available on the Vanilla Plus site for download, and so you can get the full details and listen to it again, pass it along to your colleagues. So on behalf of Vanilla Plus, I thank you very much. Goodbye.